Assalamu alaikum wa rahmatullah. I welcome you all to the fourth video. In this video, we will explain collision. From the material, there are two types of collision, elastic collision and inelastic collision. For elastic collision, momentum is conserved, kinetic energy is also conserved. For inelastic collision, only momentum is conserved. Kinetic energy is not conserved. This is because when the systems collide, some of the energies of the system are converted to heat and sound energy. For example, if I have two cars and the cars have head-on collision, we will hear sound coming from that collision, and if you happen to touch the point of collision of the two cars, you may feel some heat. The heat energy and the sound energy are part of the initial kinetic energies of the system. So this is why we said kinetic energy is not conserved. But if the collision is elastic, kinetic energy is conserved, momentum is also conserved. They say if in a collision between two bodies, the total kinetic energy is the same before and after the collision is said to be completely or perfectly elastic. Thus, in such an elastic collision, both the momentum and the kinetic energy are conserved. That is the meaning. But for inelastic, only momentum is conserved, but kinetic energy is not conserved. Then they say, let us consider two objects of masses m1 and m2. You have an object with a mass m1, the second object with a mass m2, moving with initial velocities. M1 has a velocity u1, M2 has a velocity u2 before collision, and with final velocities, meaning after they collide with each other, then M1 has a new velocity. Its velocity changes from u1 to v1, and the velocity of M2 changes from u2 to v2. So after the collision, they will have new momentum, new kinetic energies, because their velocities change after collision in the same direction. Now, if the collision is perfectly elastic, we can write two equations from the law of conservation of energy and the law of conservation of kinetic energy. Okay, from the law of conservation of energy, total momentum before collision m1 plus m1 u1 plus m2 u2 equals total momentum after collision m1 v1 plus m2 v2. And then we can write the second equation for conservation of kinetic energy. Half m1 u1 squared plus half m2 u2 squared. This is the total kinetic energy before collision. And then half m1 v1, the new velocity, squared plus half m2 v2 squared. And this is total kinetic energy after collision. This is true only for elastic collisions. Now, they say two examples of collisions that are often very nearly perfectly elastic collisions are the collisions of billiard balls and of molecules and atoms. Here they said very nearly perfectly because in nature you don't have any collisions that are perfectly inelastic, but you can have those that are nearly perfectly elastic, sorry, but you can only have those that are nearly perfectly elastic. And the examples are collisions between molecules and atoms, very small particles, and also the collision of billiard balls. Also, a tennis ball or ping pong ball that bounces back to its original height. If it bounces back to its original height, it is an indication that its kinetic energy is not lost. Because if you have a ball, for example, and you release the ball from a height, it hits the floor, the ball, we know, will not come back to its original height, because when it hits the floor, some of the kinetic energy will be converted to sound energy. So it will not have enough kinetic energy to go back to the initial height. But if a ball goes back to the initial height, it means the kinetic energy is not lost in any way, it's conserved. This is why they are making this statement that also a tennis ball or ping pong ball that bounces back to its original height after hitting a surface is said to have had an elastic collision with the surface. Okay, then in a perfectly elastic head-on collision between two bodies, the relative velocity of the two bodies are unchanged in magnitude but reverse in direction. This means if they collide, the velocities will not change, because change in velocity would mean change in kinetic energy, of course. In an inelastic collision, the kinetic energy decreases after collision, but the momentum is still conserved. The momentum is always conserved in any of the collision, whether elastic or inelastic. The only difference is in kinetic energy. If kinetic energy is conserved, it means the collision is elastic. If it is not conserved, it means the collision is inelastic. In inelastic collision, the colliding bodies stick together and move as a unit after collision. Okay, now this is a type of collision in some books we call perfectly inelastic collision. After two objects collide with each other and then they stack with each other and move with a common velocity. Like if I have a bullet, if someone fires a bullet from a gun and the gun releases the bullet and the bullet hit on a target, now the target and the bullet move together with a common velocity. Now this type of collision, it is called perfectly inelastic collision. So in this case, it means V1 and V2 are identical and I don't have to write the subscript. I can ignore the subscript and simply use V. Now it means from conservation of linear momentum that we say total momentum before collision equals total momentum after collision. It means instead of V1 and V2 here, we can remove the 1 and the 2 and we only have V since they are common, so we can factorize the V. So we have M1, M2 in bracket, and here is the V outside the bracket after the factorization. So if we are told that the objects stuck together after collision, we will only say, okay, this is the total momentum before collision is equal to, then we ignore this one and use this one instead because they have common velocity v. We don't have to use this with v1, v2. Similarly, there are kinetic energies also before collision. We can write kinetic energy before collision half m1 u1 squared plus half m2 u2 squared. But then after collision, the kinetic energy that is from the equation here, look at after collision, this is what you have after collision. But you remember that v1 and v2 are identical, and when you use v here, you can factorize the v common to them, and when you do that, it means I can rewrite this equation simply as half open bracket m1 plus m2, meaning I will just add the masses of the two bodies that stack together, and then I have v velocity common to them. I don't have to say v1, v2, and then I will square it. So kinetic energy after collision will be this is equal to what I have here. For a completely inelastic collision, the kinetic energy before collision is greater than the kinetic energy after collision. We explained this by saying most of the kinetic energy is converted to heat and sound energy when they collide. So the total energy they have before collision will be greater than the total energy they have after